this lesson, we will review some of the basic concepts in geometry and trigonometry that you would require in this class. As a matter of fact, these concepts will repeat themselves over and over and over. Therefore, it is essential that you pay attention, and if you have any questions, please do not hesitate to ask. Now, we are going to use the Pythagorean theorem in deriving some identities. We have here this is a right angle triangle. Let's call this angle theta and this angle alpha. This side here is C, this is A, this is B. Obviously, A squared plus B squared is equal to C squared. We know that sine theta is opposite, which is A, divided by the hypotenuse, which is C. Cosine theta is adjacent, which is B, divided by the hypotenuse, which is C. And the tangent of theta is opposite, which is A, divided by the adjacent, which is B. But what do you notice? You realize that A squared plus B squared is equal to C squared. This would mean that C sine theta all squared plus C cosine theta all squared is equal to C squared. This is C squared sine squared theta plus C squared cosine squared theta all equal to C squared. If we simplify, you will clearly see that sine squared theta plus cosine squared theta will be equal to 1. This gives us the first Pythagorean trigonometric identity. Now, there are some identities which really are not Pythagorean in nature, but you will be required to remember. For example, the sine of A plus B is equal to sine A cosine B plus sine B cosine A. The sine of A minus B is equal to sine A cosine B minus sine B cosine A. Let me do an example. Sine 2x can be rewritten as sine x plus x, which is the same as sine x cosine x plus sine x cosine x. This is the same as 2 sine x cosine x. So we can therefore conclude that sine 2x is equal to 2 sine x cosine x, and this will become very handy in projectile motion. Another example will be cosine 2x, which can be, sorry, we haven't talked about that one yet. So we have here cosine A plus B will be equal to cosine A cosine B minus sine A sine B. Similarly, cosine A minus B is equal to cosine A cosine B plus sine A sine B. This is another set of trigonometric identities that you should be able to remember. Let's do an example. Cosine 2x is the same as cosine x plus x which is equal to cosine x minus sine x sine x. This is the same as cosine square x sine square x. So this gives us cosine 2x, which is actually a little bit different from sine 2x. But remember that sine x squared plus cosine square x is equal to 1. That would mean that sine square x is equal to 1 minus cosine square x. If we substitute back in that expression, we're going to have cosine 2x equal to cosine square x minus bracket 1 minus cosine square x. This is the same as cosine 2 cosine square x minus 1, which is another way of representing this formula. Or you can as well see that cosine square x is the same as 1 minus sine square x, which would mean that cosine 2x will be equal to 1 minus sine square x minus sine square x, which will be equal to 1 minus 2 sine square x. So this is another way of representing cosine 2x. Now, while I may not bother you in class with so many of these derivations, my major concern or my major objective here is for you to be able to remember this when you have to remember this. If you have any questions, please ask in the discussion forum. Well, let me see. How about we do one more example that can actually make some sense. Example 3. If we have phi sine 7 pi over 6, we need to calculate the value of sine 7 pi over 6. Sine 7 pi over 6 is equal to, can be rewritten as sine pi plus pi over 6, which can still be written as sine pi cosine pi over 6 plus cosine pi sine pi over 6. This is the same as 0 multiplied by root 3 over 2 plus negative 1 multiplied by half, which will give us negative half. So in this example, we really have simplified this expression. Thank you so much.